4.5 billion years of planetary history, 400 million years of complex life, 150 million years of dinosaur dominance, 300 years of industrial civilization. We assume without question that we are the first technological species this planet has produced. But what if that assumption is wrong? What if Earth has witnessed this story before and simply forgot? The question sounds absurd at first, like science fiction rather than legitimate inquiry. Yet in 2018, two respected scientists published a paper that asked precisely this. Adam Frank, an astrophysicist at the University of Rochester, and Gavin Schmidt, a climate scientist at NASA's Goddard Institute, posed a deceptively simple question in the International Journal of Astrobiology. If an industrial civilization had existed on Earth millions of years before our own, would we be able to detect it? They called their thought experiment the Silurian Hypothesis, named after fictional intelligent reptiles from Doctor Who. The scientists were not suggesting such creatures actually existed. They were probing something more fundamental. Whether our confidence that we are alone in Earth's history rests on evidence or merely assumption. Consider the scale of time involved. Complex life has existed for at least 400 million years. Land animals have walked the continents for nearly as long. Dinosaurs dominated for over 150 million years, a span so vast that Tyrannosaurus rex lived closer in time to us than to Stegosaurus. Our own species has existed for roughly 300,000 years, and our industrial civilization spans only 3 centuries. If you compressed all complex Earth history into a single year, our entire industrial existence would occupy less than 1 minute before midnight on December 31st. Everything we have built would fit into that final sliver of time. Now ask yourself what would remain of another civilization that rose and fell during that vast expanse. A civilization lasting perhaps 10,000 or even 100,000 years. How much trace would survive millions of years of erosion, burial, subduction, and metamorphism? The uncomfortable answer is almost nothing. The Earth is not a museum preserving the past. It is a recycling system that grinds down mountains, subducts ocean floors, and transforms rock through heat and pressure. Nothing on the surface is permanent. Less than 3% of Earth's surface today is urbanized. The footprint of all human civilization covers a tiny fraction of the planet. Project that forward 1 million years. Our cities would be buried under sediment or ground to dust by glaciers. Our monuments would dissolve in acidic rain or collapse under their own weight. Even our most durable structures built from stone and concrete and steel would succumb to relentless geological forces. The only traces that might endure are chemical signatures embedded in sediment, anomalies in carbon isotope ratios, unusual concentrations of heavy metals, spikes in radioactive elements. Evidence not of civilization itself, but of its effects on the environment. This is where the thought experiment becomes unsettling, because we have found such anomalies in the geological record. About 56 million years ago, something strange happened. Over perhaps a few thousand years, massive amounts of carbon were released into the atmosphere. Global temperatures spiked by 5 to 8 degrees Celsius. The oceans acidified. Species went extinct. Scientists call this the Paleocene-Eocene thermal maximum, and they still debate what caused it. The leading theories involve volcanoes or methane release from ocean sediments, natural explanations that are almost certainly correct. But the Silurian hypothesis asks us to consider what we would look for if we wanted to distinguish between a natural carbon release and an industrial one. The fingerprint of industrial activity in the geological record might look remarkably similar to certain natural events. Rapid carbon injection, temperature spikes, ocean chemistry changes. These are the signatures we ourselves are leaving. If we found them in the deep past, we would likely assume they were natural. Frank and Schmidt emphasized that they strongly doubt any such civilization existed. Their paper is a thought experiment, not a claim, but it reveals something important about scientific inquiry. It shows us the boundaries of what we can know and the assumptions we make without realizing it. Evidence of a previous industrial civilization might be essentially undetectable after just a few million years. The problem begins with fossilization. The process by which organic remains become preserved in stone is extraordinarily rare. Only a tiny fraction of all organisms that have ever lived leave any trace in the fossil record. Most creatures that die simply rot away and vanish. Scientists estimate we have fossil evidence of perhaps 1% of all species that ever lived. The vast majority of life left no record whatsoever. Human beings have existed in our current form for 300,000 years. For most of that time, we lived as hunter-gatherers, leaving almost no trace. Even our bones are vanishingly rare in the fossil record. The oldest exposed surface on Earth is only about 1 million years old. Everything else has been buried, eroded, subducted beneath tectonic plates, or transformed by heat and pressure into something unrecognizable. The Earth's crust operates as a continuous recycling system. Continental plates dive into the mantle and melt. Mountains rise and crumble. Rivers carve through stone and carry it to the sea. What would a civilization actually leave behind? We can examine our own impact as a model. We have released roughly 550 billion tons of carbon into the atmosphere since the Industrial Revolution. This carbon has a distinctive isotopic signature that will persist in marine sediment for millions of years. We are causing a mass extinction with species disappearing at rates 100 to 1,000 times higher than the natural background rate. The fossil record will show this as a sudden collapse of biodiversity, followed by expansion of generalist species. We produce 400 million tons of plastic every year, much of it ending up scattered across every corner of the globe. These synthetic polymers will persist and become incorporated into sedimentary rock, forming a distinctive layer that has no natural equivalent. Between 1945 and 1963, above-ground nuclear weapons testing released radioactive isotopes that spread across the entire globe. Plutonium, cesium, and other radionuclides created a global marker that will persist for tens of thousands of years. But here is the crucial question. If we found such signals in the deep past, would we recognize them for what they are? Radioactive isotopes can be produced by natural processes. Carbon isotope anomalies could be caused by volcanic activity or methane release. Extinction events could be triggered by asteroid impacts or climate change. Science works by looking for natural explanations first, which is appropriate and necessary. But this methodological principle also creates a blind spot. If something unusual was caused by a technological civilization, we might not recognize it because we are not looking for that explanation. Consider what happens to evidence over geological time. Erosion grinds everything down. The Grand Canyon, over a mile deep in places, was carved by the Colorado River over roughly 5 to 6 million years. This is what water does given enough time. Imagine a city built on an exposed surface. Frost would crack the stone. Acid rain would dissolve the concrete. Wind and water would carry away the fragments. Given 10,000 years, little would remain above ground. Given 1 million years, nothing would be recognizable. Plate tectonics adds another mechanism of destruction. The Earth's surface is divided into roughly 15 major plates that move a few centimeters per year. Where plates collide, one often slides beneath the other in subduction. The subducting plate descends into the mantle, carrying everything on its surface with it. Sediment, rock, fossils, artifacts all melt into magma. Scientists estimate that no oceanic crust older than about 200 million years exists today. Everything older has been subducted. This means any evidence of activity that occurred on the ocean floor before that time is simply gone, melted, and reincorporated into the planet's interior. Even continental crust, which is more durable, is not permanent. When rock is buried deeply enough or subjected to enough heat and pressure, it changes. Minerals recrystallize. Structures become deformed. Fossils stretch and distort. The oldest rocks on Earth have been so thoroughly metamorphosed that reading their history is extraordinarily difficult. The deep past is not merely distant, it is transformed. The strongest argument against a previous civilization is the presence of easily accessible resources. We found coal and oil near the surface in deposits that had accumulated over millions of years. If a previous civilization had exploited these resources, we would expect to find them depleted. The fact that they were waiting for us suggests no one extracted them before. This is a good argument, but it has limits. A civilization that arose before the Carboniferous period, before the great forests that became coal even existed, would have had no fossil fuels to exploit. Such a civilization would have developed entirely different energy technologies. A previous civilization might have left traces we simply do not recognize because we are looking for the wrong things. There is also the question of duration. Our industrial civilization is roughly 300 years old. A future geologist examining sediment from our era would see a spike of carbon and chemicals and radioactive isotopes lasting perhaps a few hundred years. After millions of years, that spike would be compressed into a layer perhaps a few centimeters thick. Easy to miss, easy to misinterpret. Frank and Schmidt conclude their paper with epistemic humility. The balance of evidence suggests we are alone in Earth's history, but asking the question reveals useful insights about the limits of our knowledge. The geological record is incomplete. Our methods have blind spots. The absence of evidence is not proof of absence, especially when the evidence might be inherently difficult to detect. It also reveals something about the future. If we want to leave a lasting mark on Earth's history, we are already doing it. The radioactive fallout from nuclear testing will persist for ages. The carbon we are releasing will alter isotope ratios in sediment around the world. The mass extinction we are causing will appear as a clear boundary in the fossil record. We are writing ourselves into the rock. Future geologists, whether human or otherwise, will find us there. But will they understand what they have found? Will they recognize the signature of a technological civilization? Or will they assume all ancient events must have natural causes? Across cultures and continents, humans have told stories of lost civilizations. Atlantis, Lemuria, Mu, the land of the gods before the flood. These stories are not evidence, but they are interesting because they are so persistent. Why do so many cultures remember a time before time, a golden age that ended in catastrophe? Perhaps these are simply fantasies, projections of human desires onto an imagined past. Perhaps they are distorted memories of real but mundane events, floods and earthquakes and the collapse of Bronze Age cities. or perhaps buried deep in our collective memory, there is a fragment of something we have forgotten. The flood myth is nearly universal. Cultures across the world tell stories of a great deluge that destroyed an earlier world. These stories cannot all be copying each other. Many come from cultures that had no contact. The simplest explanation is that they reflect real experiences of flooding at the end of the last ice age, roughly 12,000 years ago. Global sea levels rose dramatically as ice sheets melted. Water locked in glaciers poured into the oceans. Sea levels rose by over 100 meters, flooding coastal plains that had been inhabited for thousands of years. Coastal populations were displaced. Memories of these events could have been transmitted across generations and transformed into mythology. In southeastern Turkey, a hill called Göbekli Tepe hides a secret that remained unknown until the 1990s. Beneath the surface lie massive stone structures, circular enclosures ringed by T-shaped pillars, some standing over 5 meters tall and weighing up to 50 tons. The pillars are carved with intricate reliefs of animals. Carbon dating revealed the impossible truth. The oldest structures were built around 9,600 BCE, making them over 11,000 years old. They predate Stonehenge by 6,000 years and the Egyptian pyramids by 7,000 years. They were built by hunter-gatherers. This discovery inverts the conventional story of human development, which held that civilization followed agriculture. Göbekli Tepe was not a settlement, but a ritual center, a place of pilgrimage where people from across the region gathered for ceremonies and feasts. The site was deliberately buried around 8,000 years ago after roughly 2,000 years of use. People filled in the enclosures with earth and rubble, intentionally covering the pillars. For over 9,000 years, Göbekli Tepe lay hidden. The people who built it left no written records. Their descendants forgot what their ancestors had created. Knowledge of this place simply vanished from human memory. This is the edge of memory, the boundary beyond which direct transmission fails. Without writing, even the most impressive achievements can be forgotten. Göbekli Tepe reminds us that our knowledge of the past is incomplete, that evidence can remain hidden even when it is massive and elaborate. 12,800 years ago, Earth was warming as the Ice Age ended. Then something happened. Within perhaps a single year, temperatures in the northern hemisphere plunged. In Greenland, temperature dropped by as much as 14 degrees Celsius almost overnight. The warming trend reversed. Ice sheets stabilized or began advancing again. This cold period, called the Younger Dryas, lasted roughly 1,200 years. The mainstream explanation involves changes in ocean circulation as meltwater disrupted the thermal circulation, bringing warm water to northern latitudes. But there is another theory. In 2007, researchers proposed that the Younger Dryas was triggered by a cosmic impact. They suggested that a comet or asteroid struck Earth approximately 12,900 years ago, causing massive wildfires, darkening skies with dust, and triggering rapid cooling. The debate continues, with proponents pointing to unusual materials in sediment layers. Spherules of glass and metal, nanodiamonds, elevated platinum, and iridium, shocked quartz. Critics challenge each finding, proposing alternative explanations. What makes this debate relevant is its implications. The Younger Dryas began roughly when the great megafauna of North America went extinct. Mammoths, mastodons, giant ground sloths, and dozens of other species vanished. The Clovis culture disappeared at almost exactly the same time. A catastrophic event could explain the pattern, pushing ecosystems already stressed over the edge. This is the kind of event that could erase memory of what came before. A catastrophe severe enough to kill most of the population and disrupt social structures would create a discontinuity in the historical record. Subsequent generations would remember only fragments distorted by time. The geological record does not contain evidence of previous industrial civilizations. This silence is the strongest argument against their existence. But the Silurian hypothesis asks us to examine this silence carefully, to understand not just what the record says, but what it is capable of saying. If a civilization existed 50 million years ago and left similar traces to our own, what would remain? The radioactive signature would be long gone. Plutonium has a half-life of 24,000 years. After 50 million years, not a single atom would remain. The carbon isotope anomaly might still be visible, but compressed into a thin layer easily confused with natural events. The extinction signature would be harder to interpret as the fossil record becomes sparser with age. Synthetic compounds would be degraded beyond recognition. Physical artifacts would be entirely absent, not because they never existed, but because Earth would have destroyed them completely. The uncomfortable conclusion is that a civilization similar to ours, if it existed 50 million years ago, would leave traces difficult or impossible to distinguish from natural processes. We would see anomalies but attribute them to volcanoes or asteroid impacts, because those are the explanations our methods are designed to find. This does not mean such a civilization existed. It means we cannot be certain it did not. The silence in the stone is real. It tells us that no civilization has left obvious, unmistakable evidence in the deep past. But silence does not tell us that previous civilizations definitely did not exist. It tells us we cannot know for certain. This uncertainty is uncomfortable, but honest science acknowledges what it does not know. We are probably alone in Earth's history. The evidence points that way, but probably is not certainly, and the margin of uncertainty reminds us that the universe is stranger than we imagine. What will remain of us? We are writing ourselves into stone in ways that will persist for ages. The mass extinction we are causing will appear as a sharp boundary in the fossil record. Below the boundary, diverse ecosystems. Above it, impoverished communities dominated by generalists. The carbon isotope spike, elevated nitrogen from fertilizers, heavy metals from industry, plastics and synthetic chemicals, radioactive isotopes from weapons testing. These signatures will tell a story. A species that discovered how to unlock energy stored in ancient carbon. A species that transformed the atmosphere, the oceans, the surface of the land. A species that spread across the globe and remade the world. For a brief moment, this species dominated. It extracted resources, built structures, generated waste. It altered the climate, acidified the oceans, drove countless species to extinction. Then it was gone, or perhaps it persisted in some form, but the damage was done. The evidence was preserved in stone. This is what we are leaving behind, not a story of triumph, but of impact, of disruption, of change so rapid the geological record will show it as an instant. Future observers will see us the way we see the asteroid that killed the dinosaurs, as a catastrophe, as a force of destruction, as a cause of mass extinction. We do not intend to be remembered this way. We think of ourselves as creators. But the geological record does not preserve achievements. It preserves impacts. There is perhaps a different story that could be told, a story of a species that recognized its impact and changed course, a story of wisdom rather than destruction. This story is still being written. The outcome is not determined. We have the knowledge to understand what we are doing and the technology to do things differently. Whether we will choose a different path remains to be seen. But time is short. The carbon is already in the atmosphere. The species are already extinct. The plastics are already in the ocean. The radioactive isotopes are already in the sediment. Whatever choices we make now, the record of what we have already done is permanent. It will outlast our cities, our monuments, our civilizations. It will be readable in the rocks for millions of years after the last human is gone. The Silurian hypothesis began as a thought experiment testing the limits of detection methods, but it has deeper implications. It asks us to think about our place in time, about the permanence of our achievements, about what we want to leave behind. We are temporary. Our lives last decades, our civilizations last centuries or millennia. Even our species will eventually be gone. The Earth has seen countless species rise and fall, but we are here now. We have the ability to choose. We can continue on our current path and leave behind a record of destruction, or we can change course and leave different evidence. A species that learned, that adapted, that found a way to persist. The choice is ours. The past is vast and mostly lost. The future is uncertain, but the present is ours. And the choices we make today will echo in the rocks for millions of years.